Hello again, Year 9. So here is some stuff about trigonometry. So we're going to keep going with some trig and we're going to do some examples now, okay? So we're going to do some SOH CAH TOA examples. So let's have a go at finding some unknowns using our trigonometric ratios that we normally use. And you'll have to excuse some background noise because people are just walking in. Alright, so if this side is 5, this side is 12, and we don't know what this angle is, what would we use? Well, let's have a look at what information we have. Whoa, sorry. We've got the opposite and we've got the hypotenuse. So let's use SOH because we've got the opposite and the hypotenuse. So let's use our sine rule. So sine theta. So if we knew the angle, we would put that in here, but we don't. So we're just going to write sine theta. So remember, this stands for sine equals opposite over hypotenuse. Yeah? So sine theta equals opposite over hypotenuse. We're just putting in the numbers from the triangle that match the pieces of information we need. So this is actually quite easy. What we need to do now is get rid of the sine because we only want the theta left by itself, don't we? Now remember, to get rid of this, we do the opposite, which is just the inverse of it. Remember that little button on your calculator? So you just do the inverse of sine 5/12. Type that straight into your calculator and you will end up with 24.62 degrees, okay, because it's an angle, so we're talking about degrees. Excellent, so that's not too difficult, I hope. Now let's have a go at finding an unknown side. So we'll draw another triangle. So let's say we have a triangle like this and we know that, well, let's say the hypotenuse is the unknown this time. We'll call this one 4 and we'll make this angle 60 degrees, okay? So once again, what do we know? Well, we know the opposite. Why is it doing that? We know the opposite and we know the hypotenuse. Opposite and hypotenuse. So we're still going to use our sine rule. So sine, and this time we're not going to write theta. We're going to write 60 because we know the angle is 60. So sine 60 equals opposite, which is 4, over hypotenuse, which is x. Okay? So this is the information we have. We just put it straight into the formula. Now what we want to do, slightly different to the first one, we want to move things around until we end up with x on its own. Now because x is on the bottom of the fraction, we're going to have to move that first. Even though we want to get it on its own, we need to move it first because we have to move the bottom of the fraction first, okay? So it's currently divide, so now we're going to make it times. X times sine 60 equals 4. Because we've left the 4 here, we've just times the x away to get it over the other side. Now what we want to move is the sine 60, so let's leave the x where it is, and we've still got the 4. Now here it's x times sine 60, so we're going to do the opposite and divide. And you just type that straight into your calculator and you end up with 4.62. So x is 4.62, okay? Now hopefully that makes sense. You just want to move things around until you get x on its own, okay? If not, go back and watch it again. Let's have a go at doing another example, all right? So what if we had a triangle that looked like this? Remember, always has to be right-angled triangles, okay? Let's call this one 6. This can be our unknown angle, and let's say this one's 11, all right? Now, what information do we have? We have the adjacent. This is the adjacent, and we have the hypotenuse. We have the adjacent and the hypotenuse. Well, this fits CAH, doesn't it? So we're going to use our cos ratio this time because that's the information we've been given. We do not know the opposite. The opposite would be here if we had it, but we don't have it. So cos this time, not sine, cos theta, because we don't know the angle, equals adjacent over hypotenuse. All right? Now this is just like the first example we did over here. To get rid of cos, we're just going to do the inverse of cos. Just a button on your calculator, type this straight into your calculator, and you will end up with 56.94 degrees. Remember, we're talking about degrees because this is an angle. All right? So once again, all you want to do is get rid of the cos, and you just do the inverse of the cos. It's just a button on your calculator. Now, if we had an unknown side, let's have a go at doing that. Let's make the hypotenuse 23, let's make the angle 48, and let's make this x. So once again, we don't know the opposite. The opposite would be here, but we don't know it. We've got the adjacent, and we've got the hypotenuse, so it's cos again. Cos 48, because we know the angle this time, don't we? Equals adjacent over hypotenuse. Excellent. Now, this one's a bit easier than the last one because 23 is on the bottom and that's the bit we want to move. So we always write it at the front. That's the correct way to write it. So 23 cos 48 equals x. Okay, we're just going to write it just like this. You move the bottom fraction all the way over to the front. Just like what we did over here, we moved the x from the bottom over here to the front of the equation over here. So that's what we've done. Type that straight into your calculator and you end up with 15.39. Okay? So once you get to this stage, just type it straight into your calculator and you'll have everything you need. All right, let's do an example of tan now. All right, so if we draw another triangle, let's say this is our unknown angle. This side can be 9 and this side can be 6. Obviously, I'm not drawing to scale. Okay, so this time we have the opposite and we have the adjacent. We do not have the hypotenuse, so we have the opposite and the adjacent. So we must be using TOA. So we must be using tan. So tan theta, because we don't know the angle, equals opposite, which is 6, over the adjacent, which is 9. So once again, we want to get rid of tan. So all we do is the opposite, which is just the inverse of tan of 6 over 9. Type that straight into your calculator and you get 33.69 degrees. Okay, and that's what the angle would be. Now, if you had an unknown side, these are quite wonky still. I'm still getting used to drawing on this, sorry. So let's call that one 50, 31, and x. All right, so we know the opposite is over here, and we know the adjacent. So tan 50 this time, because we know what it is the opposite over the adjacent. So we want to get rid of the 31 because we want to get x on its own. The point is to get x on its own. So let's move 31. It's currently a fraction, which means divide. So we're going to times 31 tan 50 equals x. Type that straight into your calculator and you end up with 36.94. Okay, and that would be the length of the unknown side. Hopefully that is enough information for you. If not, go back and watch it again and you should be right.